Let's move on to our misbehaving query. Let's execute the query with reasonable optimized for values, 500,000 and 860,000. So SQL Server can allocate enough amount of memory so the sort happens in memory. Let's execute the query. The query is fast, takes less than a second, around 600 milliseconds elapsed time, the duration, and 625 milliseconds CPU. Again, you see 600 milliseconds elapsed time and around 600 milliseconds CPU. Let's change the max degree of parallelism to 0. So this query can use all my 4 CPU cores. Let's execute the query. There you see the elapsed time is nearly the same. The CPU usage is higher. Let's execute the query again. The elapsed time is nearly the same. CPU usage is higher. Now the query is running very slow. The query is taking more than 6 seconds, 6.7 seconds. Let's execute the query again. The query is fast this time. That's what I meant by this query is misbehaving. This query took 416 milliseconds, elapsed time, the duration. The query with max DOP1 took 600 milliseconds. This query, executing in parallel using all my 4 CPU cores, took 2/3 of the execution time of the serial query. This query took 827 milliseconds of CPU, higher than the serial execution. The serial execution took 600 milliseconds of CPU. We will talk more about parallel query efficiency later in this webcast. This is what I meant by misbehaving. Sometimes the query executes with 416 milliseconds elapsed time. Sometimes the query takes 6.7 seconds elapsed time. Like in previous webcast, I will show you the reason. Once you understand the reason, it will be very easy for you to find a solution. Before that, let's continue with the conversation about how one can develop deep SQL Server knowledge. I suggest 2 more options. We will discuss one in this webcast and the other in a future webcast. Conferences, trainings, and workshops are a great way to learn. If you ask me which conference to attend, I will suggest PAS Summit. This happens every year. If for some reason you cannot attend it in person, then I suggest you buy the session recordings which are available in DVD. If you are living in Europe, there is a possibility to attend the European PAS conference. But I would suggest you try to attend the PAS Summit in the US or buy the PAS Summit session recordings in DVD instead. This is because I can assure you the best content is always delivered in the US. I worked for Microsoft in the past, in Redmond, USA and Vienna, Austria, and I can tell you personally, the key developers in the SQL Server development team will be willing and deliver a session in these conferences if they happen in Seattle. Key developers with real product shipment responsibilities will not easily travel to Europe to speak in a conference. This opinion is from my personal experience. Mr. JLR told me he is a busy guy and doesn't have much time to attend these conferences. I told him in that case, just buy the PAS Summit session recording DVDs. Such in-person conferences make sense if you are looking for contacts, especially you are selling third-party software or hardware or consulting services and want to develop new clients or want to partner with these third-party companies to profitably resell or promote their products and services. If your primary goal is to gain knowledge and you decide to socialize in your own neighborhood, then these in-person conferences are not the best for you since you cannot attend parallel tracks at the same time anyway. If you have no time for any of this, then I suggest you at least view the 24 hours of PAS session recordings. There is no excuse for that. It is totally free. It costs you nothing. The query is misbehaving. The performance is unpredictable, unreliable, meaning sometimes the query is fast and sometimes slow. This is because the way SQL Server allocates and distributes the memory across the threads when a query is run in parallel. In this case, we are sorting the rows, 300,000 rows. the query is executing in parallel with 4 threads over 4 CPU cores. SQL Server divides the memory across these 4 threads equally, but the threads might not process the same amount of rows, some less, some more. It all depends on the current load over different CPU cores on the server. There is this parallel page supplier which hands out certain number of pages to every thread, and once they are done processing these pages, these threads will be handed out more work, more pages. If for some reason one thread processes less rows, due to the CPU core used by that thread is also busy with other SQL Server load or external load, that thread will process less rows and sort less rows. As a result, other threads will process more rows and will have to sort those more rows. Since the memory was equally divided across these 4 threads, some threads will still sort to TempDB. You can see the number of rows processed by each thread by inspecting the execution plan. You can count how many threads spill to TempDB by profiling sort warnings event in the profiler. Let's start the profiler. Tools, SQL Server Profiler. Let's connect to the instance SQL Workshops. Let's choose blank template. Under errors and warnings, let's choose sort warnings. Let's execute our query with some changes. The query is the same. We are selecting between 500,000 and 800,000. Optimize for value 500,000 and 860,000. So optimizer allocates enough memory. We execute in parallel, max DOP 0. In addition, what I am doing is I am resetting wait stats like we did before, and finally I am collecting CX packet wait times. And I also collect get date before the query starts and after the query completes, so I can show date diff in milliseconds. Let's include actual execution plan and let's execute this query. This query took 423 milliseconds to complete. CX packet wait time is 1007 milliseconds. Let's execute the query again. There you see 426 milliseconds and 1007 milliseconds CX packet wait time. Let's inspect the execution plan. Let's move our cursor on top of the sort operator. There you see estimated number of rows is 360,000. Actual number of rows is 301,000. Let's right click properties on the sort operator. There you see our 4 threads handle nearly same amount of rows, 75,000 rows, 77,000 rows, 73,000 rows, and 74,000 rows. Thread 0 is the coordinator. It did not handle any rows. So since all the threads handle equal amount of rows, there were no spills. Let's look at the clustered index seek. Let's right click properties. There you see the actual number of rows is again 300,001, and all threads handle nearly equal amount of rows. There will be no spill. When we go to SQL Profiler, there you see there is no sort warnings. The query is fast. Let's execute our query again. Let's go to a new query window. Let's paste our query. Let's include the actual execution plan. Let's execute the query. The query took 956 milliseconds. The query took 956 milliseconds. Now you see the query is much slow. Let's wait for this query to complete. Let's inspect the execution plan. Let's move the cursor on the sort operator. There you see the actual number of rows again is 300,001 and the estimated number of rows is 360,001. Right click properties on the sort operator. There you see the amount of rows that are sorted by these threads are not the same or not nearly the same. Thread 0 is the coordinator. It did not sort any rows. Thread 4 sorted only 52,000 rows compared to other threads sorting 82,000 rows. It looks like Thread 4 was running on a CPU core, and that core seems to be busy with some other workload, so it processed less number of rows, increasing the load on other threads, and other threads spilled to TempDB. Let's go to our profiler. There you see 3 sort warnings because 3 threads spilled to TempDB. Mr. JLR tells me that Oracle developers and DBAs earn more salary and bonuses in real world than SQL Server developers and DBAs. I asked him why. Mr. JLR says when management asks why this report or job runs slow, the Oracle developers and DBAs understand the issues very well and provide detailed answers, and the management likes this. When Oracle developers and DBAs are tasked to tune these reports and jobs, they do have a clear approach, and Mr. JLR tells me this is all due to very strong understanding of the so-called Oracle fundamentals, Oracle architecture by the Oracle colleagues. Mr. JLR says when it comes to SQL Server, the developers and DBAs will start like this. Yes, the report or job is running slow. You know, maybe the statistics is not up to date. Or maybe we have to reorganize or rebuild the indexes. Or maybe we have to reduce max degree of parallelism. They don't have a clear understanding, and this reflects in their salaries and bonuses. When the query was fast running parallelly, the query took 426 milliseconds and the CX packet wait time was nearly 1007 milliseconds. When the query was slow, the elapsed time was 7 seconds and the CX packet wait time was 21 seconds. Let's not run away from high CX packet wait time and disable max degree of parallelism. Let's face it, like Oracle colleagues. Let's tune this query. Let's rewrite the query to include a redundant join. I'm including this example so you can better understand the optimizer. New query. Let's cut and paste this query. There you see I have table 7 2 times, inner join on column 1 equal to column 2. Otherwise this query is the same. Let's include actual execution plan and let's execute the query. The query took 1.1 second to complete. Let's inspect the execution plan. Let's move the cursor on the sort operator. There you see actual number of rows 300,001. Let's right click properties. There you see all threads processed nearly equal amount of rows, avoiding a spill, so this query did not take 6.7 seconds. Let's analyze the execution plan further. Let's look at the cluster index seek. Let's move the cursor. There you see estimated number of rows is 360,001, but actual number of rows is 300,001. Let's right click properties. There you see each thread handled different amount of rows, but the parallelism operator using the repartitioning streams repartition the rows. So all rows are now equally distributed across the threads. This query provides predictability. The query took 1.1 second irrespective how many rows were processed by each cluster index seek threads. The repartition streams, the partition operator redistributed the rows, so the query has predictable performance. This is not a perfect solution. The performance is predictable, but the CPU usage is high due to extra join, the redundant join. Mr. JLR told me the misleading message about CX packet is being communicated year after year. Pass Summit 2008, 24 hours of pass, and Pass Summit 2009. Mr. JLR pointed out the PowerPoint slide was slightly altered in the Pass Summit 2009, and now the bullet point states CX packet direct result of inefficient parallel processing. Mr. JLR told me the 24 hours of pass session recording are free to watch, and the session to look for is analyzing file and wait stats. Mr. JLR asked me to go to the Internet Explorer, open a new tab and type 24hours.sqlpass.org. There he showed me to click on register today. page down, there he showed analyzing file and wait stats. This is the session you have to look for. Mr. JLR asked me to show how to decrease CX packet weights and improve performance without reducing max degree of parallelism to better understand CX packet weights. Let's execute our query again without the redundant join. But what we are going to do is inflate the amount of memory SQL Server needs to sort. So I am going to say 900,000. The best solution to address this issue is to simply allocate more memory, over allocate memory to our query so each thread can perform in-memory sort. How much memory should we over allocate? It depends on the requirement. I want to remind you, with these queries, there is always a possibility for a thread to spill the sort to 10 dB, even if the optimizer allocated reasonably good amount of memory due to uneven number of rows processed by each thread because of internal or external load over the CPU core that is executing the thread. So understanding this issue, this problem, and the solution will be helpful in any case. I know some of you write reports that your CEO or CIO will execute, and you have to provide predictable response time to the so-called CEO reports. And there are those billing jobs which should complete on a specified batch window. If they don't, surely you will get a call from your manager. How can you provide predictable response time? For these queries, I would suggest you simply over allocate memory. How much memory to over allocate? It's an interesting question. Since we have no idea how many rows will be processed by each thread, since that depends on current load over each CPU core, we need to look for proven engineering design process concept called factor of safety. When you design an elevator or a lift, you have to design it with a factor of safety, which is part of the requirement. When you ride on an elevator or lift next time, look around. In addition to emergency number posted there, you will also find the maximum capacity specification, like 10 people or 750 kilo or 1,650 pounds. In reality, these elevators are designed to sustain more than what is specified there. In case they were designed with factor of safety 1.5, they can in fact sustain 15 people. When SQL Server creates a parallel plan, it allocates a bit more memory than the serial plan to cover the overhead. But this does not address the uneven distribution of rows each thread processes. We have to apply this concept, the factor of safety, into our query. If we are going to sort 300,000 rows, and we tell the optimizer to optimize for 400,000 rows, this gives us a factor of safety of 1.33. If you want a factor of safety of 1.5, then you have to tell the optimizer to optimize for 450,000 rows. And again, be careful. Like I mentioned in the previous webcast, this is not a monopoly game. Don't overestimate too much memory. Others will have to pay a penalty. Even you might have to pay a penalty in case your query has to wait. In case you asked for more memory than what SQL Server currently has available, your query has to wait until other queries release enough amount of memory so SQL Server can grant the amount of memory to your query. Let's help the optimizer by setting optimize for values between 500,000 and 900,000. This way we are telling optimizer to allocate enough memory to sort 400,000 rows while we are going to sort actually 300,000 rows. Let's include actual execution plan. Let's execute the query. The query is fast, 660 milliseconds. Let's look at the execution plan. Right click properties. There you see all threads process even amount of rows. Let's execute the query again. The query is slow, taking 5-6 seconds. Let's look at the execution plan. There you see one thread processed only 24,000 rows, leading other threads to process more rows and initiating a spill to TempDB. Let's look at the CX packet wait time, 17 seconds. This is very high. Let's execute the query again. The query is fast now. How do you provide predictable performance? Let's increase the optimize for values. Let's tell the optimizer to optimize for 450,000 rows while we are going to sort only 300,000 rows, a factor of safety of 1.5. Let's execute the query. The query took 523 milliseconds. The CX packet wait time is very less. Let's inspect the execution plan. There you see one thread did not process any rows. Other thread processed lot of rows. Even then the query was fast without spilling to TempDB. By rewriting the query without reducing or disabling parallelism, without running away from high CX packet wait time, we made the query perform well. We actually decreased the CX packet wait time without reducing max degree of parallelism and made the query perform well. Let me show you one more example to better understand CX packet waits. Before that, let me tell you, in Europe, you have the SQL Bits conference, the largest European SQL Server conference based on number of participants. It used to be free. They are changing the model, but part of it is still free. All the sessions are recorded and you can view them over the internet, all for free. This is truly a service, a non-profit service for the community. Mr. JLR cannot understand why PAS Summit and PAS Summit session recording DVDs are so expensive, even though it is also a non-profit organization. But he has some ideas that he will share with us later. The one speciality about SQL Bits conference is the sessions are selected based on prospective attendee voting. Have you been to a conference where the same session by the same speaker is hosted year after year because the speaker got the best connections to the session selection committee? This will not happen in SQL Bits. No attendee will willingly vote for the same session year after year while the content is available in the recorded format. But in all formats, books, conferences, trainings and workshops, speakers and instructors might make mistakes. This is reality. Be careful what you take home because our human brain, just like SQL Server, cannot selectively roll back certain incorrect transactions. You got to filter them as you stuff them onto your brain. My recommendation is to suspect everyone and every advice, no matter if they come from community leader or user group leader. All of us make mistakes. Ask questions. Ask for more demonstrations and just don't put up with PowerPoint slide bullet points.